This is SpaceTime Series 27, Episode 72, for broadcast on the 14th of June 2024. Coming up on SpaceTime, two tiny moons stuck together discovered to be orbiting the asteroid Dinkinesh. Astronomers believe there's an underground ocean on Saturn's moon Mimas. And NASA launches its second pre-fire satellite into orbit on Rocket Lab's Electron. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered that a tiny moonlet orbiting the main belt asteroid Dinkinesh is actually two little moons that have become melded together. Known as contact binaries, the two moonlets could provide fresh insights into the complex processes behind planetary formation and evolution. The discovery, reported in the journal Nature, was made by NASA's Lucy spacecraft, which is on a 12-year mission to study Jupiter's mysterious Trojan asteroids. Lucy swooped past Dinkinesh last November to provide mission managers with a target to test the probe's scientific instrument package and give researchers a chance to study the 790-metre-wide world close up. The name Dinkinesh was derived from an Ethiopian word for the Australopithecus fossil Lucy discovered in the Awash Valley back in 1974. Lucy, which is now actually believed to have been male, was one of the first hominids discovered with the ability to walk upright. And just like the data on early hominids derived from the Lucy fossil, the Lucy spacecraft will provide scientists with new information on the early history of planetary formation in the solar system. During the Dinkinesh flyby, scientists discovered that it was not alone in space, but that it had a small 220-metre-wide moon, which the authors eventually named Salam, the name of an infant Australopithecus fossil found in Ethiopia in the year 2000. As the Lucy spacecraft sent back more and more information to Earth, scientists discovered something surprising. Salam was not just one moon, but a contact binary, two moons melded together. The authors say this unusual arrangement challenges existing theories on how asteroids and other celestial bodies formed over time, and provides additional insights into the internal structure, dynamics, and evolutionary history of both Dinkinesh and Salam. The team are now also able to analyze features such as Dinkinesh's rotational speed and Salam's orbital pattern, as well as what materials both are possibly made from. The images taken by Lucy are also revealing a trough on Dinkinesh where about a quarter of the asteroid broke off from the main body, a ridge that formed after the asteroid's structural failure, and the contact binary Salam. The authors theorise that Dinkinesh's fast spin motion, boosted by the uneven reflection of sunlight on the asteroid's surface, would have caused it to shed and eject rocky debris into orbit. And some of that debris could have aggregated to form Salam, while another portion of the fragments rained back down on Dinkinesh's boulders, creating the ridges imaged by Lucy. The study's lead author, Hal Leveson from the Southwest Research Institute in Boulder, Colorado, says that one of the things that's critical to understanding how planets like the Earth got here is understanding how objects behave when they hit each other in space. And to understand that, astronomers need to understand their structural strength. Basically, planets form through accretion as smaller objects, like asteroids orbiting the Sun, crash into each other. Whether the objects break apart when they hit or stick together has a lot to do with their internal structure and strength. The authors have deduced that Dinkinesh likely had some degree of internal strength which allowed it to maintain most of its form. However, just how Dinkinesh's unusual dual moons formed remains a mystery. But these new observations by Lucy at least opens the door to comparative studies with other celestial bodies. Dinkinesh and its satellite are the first two of 11 asteroids which Lucy plans to explore during its mission. After skimming the inner edge of the main asteroid belt, Lucy heads back towards the Earth for a gravity assist in December. That close flyby will fling the spacecraft back through the main asteroid belt, where it will observe the asteroid Donnell Johansen in April 2025, and then move on to begin examining the Trojan asteroids of Jupiter in 2027. This report from NASA TV.
We are going to an amazing variety of objects with this mission. And it's really almost pure luck that allowed us to get as many rich targets as we are. Literally, the planets were aligning to allow us to do this mission.
The Lucy mission is named after the Lucy fossil, the Australopithecus fossil that was discovered in the 1970s in Ethiopia. And just like the Lucy fossil transformed our understanding of hominid evolution, the Lucy mission will transform our understanding of solar system evolution.
Trojan asteroids are an interesting population of small bodies that are left over from the formation of the planets, and they lead or follow Jupiter in its orbit by roughly 60 degrees. If you just look at the gravitational attraction of the Sun and Jupiter and put something exactly 60 degrees in front of Jupiter, it's stable forever. So as a result, these objects are really the leftovers of planet formation. The stuff that went into growing Jupiter and Saturn are now trapped in these locations.
Main-belt asteroid named Donald Johanson. We named that asteroid in honor of the researcher who found the Lucy fossil. We're going to use that asteroid to do a rehearsal on our spacecraft to make sure everything is working properly so that when we get to the Trojan asteroids, we're ready to go.
We're visiting both of the Trojan swarms. In the first orbit, we're going into the leading swarm, and we're going to encounter 4 Trojan targets.
Eurybates, Ptolemy, Lucas, and Oris. And from this, we're going to sample the diversity in sizes, and colors, and compositions. The first 2 flybys happen just about 30 days apart, so it's going to be a pretty busy kickoff to the season of exploring the asteroids in the L4 swarm. And then we'll fly past Earth again and out to the L5 swarm.
The final object we're visiting, which I must admit is my favorite, is a binary object.
So that's 2 Trojans that orbit a common center of mass. It's called Patroclus and Menecius.
These objects are nearly identical in size that orbit one another.
From the Lucy mission, we're going to study the diversity of our targets because that tells us something about their origin and where they came from.
The interesting thing about small bodies in general is they are the leftovers of planet formation. If you look at the 8 planets that we know about, for example, they are highly processed because of internal processing. These asteroids are objects that really haven't changed much from when the planets assembled themselves. And as a result, by studying them, we can figure out the physical conditions of the early solar system, as well as how the planets grew and how they moved around early on.
All of that will help us form a detailed picture of what these objects really look like. Because right now, our best images are just a point of light. Even using the Hubble Space Telescope or adaptive optics on large ground-based telescopes, we can't see surface details. And it's going to take the Lucy mission to go to these targets and see what they're really made of and what they look like.
This is Space Time. Still to come, astronomers believe there's an underground ocean on Saturn's moon Mimas, and NASA launches its second pre-fire satellite into orbit on Rocket Lab's Electron. All that and more coming up on Space Time. Scientists are speculating that Saturn's moon Mimas could have developed an underground ocean as its orbital eccentricity decreased to its present value and caused its icy shell to melt and thin. Mimas is the 7th largest moon orbiting the Saturnian system. It has a diameter of 396.4 kilometres and is the smallest astronomical object known to be roughly rounded in shape due to its own gravity. But the most notable feature on Mimas' surface is Herschel, one of the largest craters relative to the size of its parent body in the solar system. Herschel measures some 139 kilometres across. That's about a third of Mimas' diameter. The massive crater gives Mimas the appearance of the infamous Death Star in the Star Wars movie franchise. Whether George Lucas knew of Mimas' appearance when he came up with the idea of the Death Star isn't known, but the idea of such an inspiration is fascinating. A report in the journal Earth and Planetary Science Letters claims previous research had already indicated that for Mimas to be an ocean world today, it must have had a much thicker icy shell in the past. But because Mimas' eccentricity would have been a lot higher in the past, the exact pathway to get from thick ice to thinner ice wasn't clear. One of the study's authors, Matthew Walker from the Planetary Science Institute, says the earlier work showed there was a pathway for the ice shell to be thinning currently, even as the eccentricity is dropping due to tidal heating. But the ocean must be very young, geologically speaking. Eccentricity is what drives tidal heating. Changes in Mimas' orbital distance from Saturn causes the ringworld's gravity to repeatedly stretch and squeeze the little moon, causing lots of internal friction, which heats up the geology. And it's that internal heat which is melting the ice, forming the subsurface ocean. Right now, Mimas' orbital eccentricity is still very high compared with other active ocean moons, such as the neighbouring Enceladus. But tidal heating isn't free. So as it melts the shell, it's also pulling energy out of Mimas' orbit, which is slowly dropping that eccentricity until it eventually circularizes the orbit and shuts the whole thing down. So the onset of melting had to have occurred when Mimas' eccentricity was between 2 and 3 times its present value. The good news is a thinning ice shell over the past 10 million years in Mimas' evolution is consistent with its current geology. Generally, when scientists think of ocean worlds, they don't end up seeing lots of craters. That's because the environment's being constantly resurfaced and ends up erasing them, like we see on Jupiter's ice moon Europa and the south pole of Enceladus. The shape, central peak and undisrupted interior of the Herschel crater, however, requires that the shell must have been thicker in the past when Herschel was first formed. Walker says in order to get that crater morphology right, the shell must have been at least 55 kilometres thick when it was hit. Craters can provide great clues as to the presence of an ocean as well as the thickness of the ice shell through their morphology. Astronomers look for things like the ratio between the crater diameter and its depth and the existence of a central peak. Mimas has a radius of just under 200 kilometres. The thickness of the outer hydrosphere, made up of ice and liquid, is roughly estimated to be around 70 kilometres. And the current estimates for the ice shell thickness are between 20 and 30 kilometres. That's based on the precession or rotational motion of the axis of a spinning body. A narrower range of 24 to 31 kilometres is calculated based on the libration or slight wobble in the rotation rate of the moon that makes it appear to nod back and forth. And that will leave an ocean depth of between 40 and 45 kilometres before one hits rock. Walker says it means we may be seeing Mimas at an especially interesting time. In order to match the current eccentricity and the thickness of constraints based on the libration measurements, Walker and colleagues think the whole thing must have started off no more than 25 million years ago. In other words, Mimas was still completely frozen until between 10 and 25 million years ago, at which point its ice shell began melting. Now, as to what changed to kick off that epoch of melting, well, that's still under investigation. This is space-time. Still to come, NASA launches its second pre-fire satellite aboard Rocket Lab's Electron, and later in the science report, a new study shows just how frequently cannabis usage can trigger psychotic symptoms. All that and more still to come on Space-Time. NASA has launched the second of a pair of Earth observation satellites designed to study how much heat the Arctic and Antarctic are radiating out into space and how that's influencing global climates. NASA's second Polar Radiant Energy in the Far Infrared Experiment, or pre-fire CubeSat, was launched aboard a Rocket Lab Electron rocket from the company's Mahia Peninsula Launch Complex 1 on New Zealand's North Island east coast.
Vehicle is fully on internal power. AFTS is green and enabled for flight.
LOX load is complete. System is in recirculation.
Stage 1 and Stage 2 tanks are pressed for flight.
High flow engine purge enabled.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Beginning pitch over. Stage 1 propulsion.
And with that, we have lift off from Launch Complex 1 of our 48th Electron mission. Ready Aim Pre-Fire is in the air and on its way to space with its NASA payload. Soon we'll be hearing the call out for Max Q, otherwise known as maximum aerodynamic pressure, which is the point during Electron's ascent where the structure is under the most amount of stress. We'll hear from the GNC operator shortly that Electron has cleared that milestone.
High voltage battery discharge is nominal.
Cleared max Q.
And that was the max Q milestone, passed cleanly through by Electron as it carries on its mission to orbit for NASA. We're now at over 18 kilometers in altitude and moving at over 2,400 kilometers an hour. Next up will be 3 actions that are performed by Electron back to back to back. The first is main engine cutoff on the first stage, when all 9 Rutherford engines will shut
Guidance
down.
is nominal.
Next is stage separation, when the booster disconnects from stage 2, and then we will have second stage engine ignition, when the Rutherford engine on the second stage lights up to carry on with the mission.
Stage 1, propulsion holding nominal. Stand by for MECO in 30 seconds. 15 seconds to staging. Entered burnout detect mode. MECO confirmed. Stage separation successful. Stage 2, ignition confirmed.
MECO, stage separation and engine start on that second stage. Electron is sailing smoothly through space so far. Past 105 kilometers in altitude and 8,350 kilometers an hour.
High voltage battery discharge nominal.
Now, although Electron is moving at over 7 times the
Stage 2
speed of
propulsion
sound, there's
nominal.
very little resistance in the vacuum of space. So the next major milestone coming up is fairing jettison, where the 2 halves of the rocket's nose cone will separate and fall back to Earth. On missions like this, where the payload is a tiny portion of our overall mass, we leave the fairing connected for a little while longer than usual.
Fairing jettison succeeded.
And that there was the call out for fairing jettison, confirming that the nose cone on Electron has split apart and fallen away in preparation for NASA's pre-fire satellite to deploy.
T plus 4 minutes and 41 seconds, Electron is travelling at speeds of 10,800 kilometres an hour and at an altitude of 174 kilometres.
Stage 2, propulsion nominal.
We're now coming up on the moment when the second stage Rutherford engine needs to perform its next action, a manoeuvre called the battery hot swap. This is a move unique to our Rutherford engine. Since its pumps are powered by batteries, by this point in the journey, we need to swap out the draining battery packs for a fresh set of new ones that will keep the engine running.
Battery
Throttling down.
hot swap successful.
Another milestone down, that was battery hot swap for the second stage Rutherford engine. All is continuing nominally for Electron, its engine, and the mission as we carry on past 210 kilometres in altitude at more than 15,000 kilometres an hour. The next actions for the second stage will then be some of its last, including shutting down the Rutherford engine for SECO before separating the kick stage and NASA's pre-fire satellite. Those milestones will happen back to back just after 9 minutes into the mission.
HVV battery discharge holding nominal.
SECO confirmed. Stage 3 separation confirmed. Nominal transfer orbit achieved.
And just like that, 9.5 minutes after lifting off, we are in space. The second stage engine has now shut down and the kick stage has separated, ready to perform its own specific maneuvers to place NASA's payload into its target low Earth orbit for the pre-fire mission.
Data from the 2 shoebox-sized satellites will allow scientists to better understand how Earth's ice, seas and weather will change in a warming world. The second satellite launch follows the launch a week earlier of the first pre-fire CubeSat. Over the next month, engineers and scientists will carefully check out both spacecraft to confirm they're operating nominally. The full mission will then begin, lasting around 10 months. The pre-fire mission will ultimately help improve climate and ice models by helping to clarify the role the Earth's polar regions are playing in regulating the planet's energy budget. Pre-fire will help scientists understand the balance between the incoming heat energy from the Sun and the outgoing heat energy being reflected off the Earth's poles. You see, the Arctic and Antarctic act like a radiator, reflecting much of the heat initially absorbed at the tropics back into space. And the majority of that heat is being emitted as far-infrared radiation. The water vapor content of the atmosphere, along with the present structure and composition of clouds, influences the amount of radiation that escapes into space from the poles. The pre-fire mission will also use its 2 CubeSats in asynchronous near-polar orbits to study how relatively short-lived phenomena like cloud formation, moisture changes, and ice sheet melting affect far-infrared emissions over time. The 2 spacecraft pass over the same part of the Earth's surface at different times of the day, giving researchers information on the changing conditions. Pre-fire's Deputy Principal Investigator, Brian Druin from NASA's Jet Propulsion Laboratory in Pasadena, California, says climate change is reshaping the entire planet's environment and atmosphere. And it's doing it in ways which scientists need to understand in order to help humanity prepare. Each CubeSat carries an instrument called a thermal infrared spectrometer. It uses specially shaped mirrors and sensors to measure infrared wavelengths. Miniaturizing the instruments to fit on CubeSats required special downsizing of some parts while scaling up other components. Equipped with advanced infrared sensors that are more sensitive than any similar instrument, the pre-fire CubeSats will help scientists better understand Earth's polar regions and improve their climate models. It'll provide observations with more accurate predictions about sea level rise, weather patterns, and changes in snow and ice cover. This report from NASA TV.
The Arctic is warming 3 times faster than anywhere else on Earth.
This is a huge problem, in part because that is enhancing melt of the ice sheet. It's leading to enhanced melt of sea ice.
All of the coastal communities around the world are now seeing sea level rise around them and experiencing increased flooding.
It will impact the future generations. They're going to inherit a planet that's going to be many degrees warmer than what we are today.
We need to have better predictions of how sea level will change, how the weather around the planet is going to change. The only way we're going to do that is to understand how the polar regions are responding to climate change.
We have this considerable knowledge gap in our understanding of Arctic climate.
Pre-fire is going to fill this important gap.
Pre-fire, polar,
radiant
energy
in the far
infrared
experiment.
So Earth's temperature is set by a balance between the amount of energy the Earth receives from the sun and the amount of energy that it emits back to space.
Most of the energy that is radiated to space from our polar regions is far infrared energy, and we have no modern satellite observations of this incredibly important energy spectrum. Pre-fire will be deploying 2 CubeSats. Over the course of a year, they're going to be measuring the far infrared energy for the very first time that is leaving the top of our atmosphere.
Each of our pre-fire CubeSats carry something called a thermal infrared spectrometer that looks down at the Earth and gathers energy being emitted from the planet at different wavelengths.
Just imagine a rainbow. When you see a rainbow, you see the different colors in the rainbow. And what happens is light gets dispersed. Similarly, we see the different wavelengths split up, and you can measure each of these wavelengths. And that's what the spectrometer does. It spectrally separates the radiation into different wavelengths.
These wavelengths were going to give us really important information about how the surface is changing in the polar regions, whether that's going from an ice-covered surface to a melted surface, or whether it's going from sea ice to open ocean.
The 2 satellites are going to be orbiting in a polar orbit around the Earth. The first satellite comes along and measures the scene over the poles. And then a few hours later, we have the second one come along in a different orbit and measure the same scene, so you understand the impact of how the energy changes in those few hours.
It's really important that we understand how much energy is being emitted by the polar regions, because that defines how cold the polar regions get. And that temperature difference between the warm tropics and the cold polar regions is actually what drives the entire weather system around the planet.
What we want to do with pre-fire is we want to take these new observations that have never been made before, and we want to improve our understanding of the climate system and improve our understanding of how climate is going to be changing.
Understanding how the sea level rises and how the ice melts is going to help us understand weather events, and that's going to have direct impact on our farmers and agriculture.
There's a real urgency to getting this information now. Things are changing so quickly in the Arctic that we may only have 5 to 10 years to respond to those changes and help protect the property and lives that may be affected by that.
And in that report from NASA TV, we heard from pre-fire principal investigator Tristan LeCure from the University of Wisconsin, pre-fire instrument lead engineer Shamila Padmanabhan from NASA's Jet Propulsion Laboratory, and pre-fire research assistant Natasha Voss from the University of Wisconsin. This is Space Time. And time now to take another look at some of the other stories making news in science this week with the Science Report. A new study has confirmed several earlier studies showing that circumcised men who have sex with other men are at a lower risk of HIV infection. The latest findings, reported in the journals of the Annals of Internal Medicine, are based on studies of some 250 uncircumcised HIV-negative men aged between 18 and 49 who had multiple recent male sexual partners. All self-reported, predominantly practicing insertive anal intercourse, and had 2 or more male sexual partners in the previous 6 months. All were planning to be circumcised. All received HIV counselling and testing. Half the men were then randomly assigned to immediate circumcision, while the remainder delayed their planned circumcision for 12 months to act as a control group. They were all tested regularly for HIV over the next year. The researchers say that 5 of the uncircumcised men became infected with HIV over the study period, compared to none in the circumcised group. However, interestingly, there were no differences in rates of infection for other sexually transmitted diseases, such as syphilis, herpes simplex virus type 2, and penile human papillomavirus. The authors admit their study was limited by a smaller than ideal group size and a lower rate of HIV infection overall than what was predicted. But they still believe circumcision could be considered alongside other forms of protection for reducing HIV transmission and AIDS. A new study shows that mature eucalyptus trees don't increase their growth rate with increased carbon dioxide in the atmosphere. Previous studies have suggested that increasing CO2 levels in the atmosphere stimulates plant growth. However, the new study, reported in the journal Nature, suggests that in some parts of the world, increased CO2 means some soil microbes hold on to their phosphorus, making it less available for trees. This is alarming news because, according to current projections, global forest growth was meant to limit the damage being caused by global warming. Medical practitioners have long known of an association between cannabis use and the likelihood of developing psychotic episodes. Now, a new study in the journal Nature Mental Health has determined how frequently dope can trigger psychotic symptoms. Scientists found that about 1 in 200 cannabis users may experience a full psychotic episode related to using the drug. The authors collated different types of studies on cannabis-associated psychotic symptoms in order to estimate how frequently they occur and what factors may increase the risk. They looked at a total of 162 separate studies, including observational research, experimental studies on THC, that's the main psychoactive substance in cannabis, and medicinal cannabis research. They say cannabis-related psychotic symptoms were more common in observational experimental studies, and some people appeared to be more at risk than others, such as younger people, people with pre-existing mental health problems, and people exposed to higher levels of THC. Well, most of us have seen them, fleeting glimpses of shadowy humanoid figures out of the corner of your eye. And if you're a skeptic or scientifically inclined, you quickly dismiss them as nothing more than optical artifacts caused by an eyelash or light reflection of some sort. But there are some out there who really believe that they're malevolent entities, perhaps of a demonic nature, or the spirits of the deceased who have not yet moved onto the afterlife. But Tim Mendham from Australian Skeptics says one shouldn't rule out sleep states and various tricks of the eye.
Shadow figures is a common thing in that common bit of evidence put forward for hauntings, etc. The whole nature of a shadow figure is that it's often seen in as dark, shadowy silhouettes, right, as the name would imply. Human-like figures, roughly. They move out of the peripheral vision of your eye. When you're sort of looking one way, you can sort of see it out of the corner of your eye. Rarely directly in front of you, but sometimes, yes. And they're fleeting and elusive, so when you try and turn and look at them, they're gone. They don't have any discernible features, largely eyes or anything like that, and they vanish abruptly. All these things would suggest that they are trick of the eyes. That doesn't stop people sort of claiming that they are real things. Yeah, the figures you do see in photographs and things, just this amorphous sort of shape, which the pro-ghost people would obviously say that's a real figure, except are they physical? Are they energy? Can you put your hand through one if you can get close to one, which people don't? Some are saying that actually they have evolved. The type of shadowy figures you're getting have changed over the years, which would imply also that they are a construct of our own society rather than any long-standing ghostly being. A ghost should be a ghost, whatever period they appear in, but apparently not. So shadowy figures are more common now than they used to be. There's various suggestions, obviously from a skeptical point of view, that there are psychological or environmental explanations that might explain these things. Yes, people see shadowy figures. That's not disputed, but they see them out of the corner of the eye largely. And what is disputed is what are they, and do they even exist? If you're seeing a shape in a low light situation, could be playing tricks on your eyes. You could be between the waking and sleeping state and half dreaming, half seeing something, which then disappears. This is a shadowy figure, not a figure of your grandfather coming back, etc., and telling you how much he's enjoying heaven. These are this vague shapes, which you often, at night, honestly, it's not very reliable evidence. And it is perhaps quite genuine, but not ghostly. People who use devices to try and track them, things like sensors, etc., but most sensors are infrared, which means there's a certain heat element in there. And the question is, do shadowy figures have heat? If they have heat, are they real? Are they physical? Are they something you can touch and grab, even though they're fairly amorphous shapes, etc.? There's a lot of issues and a lot of problems, again, with a lot of the ghost hunting gear is pretty rubbishy and can be easily sort of manipulated, often unknowingly. But as to using them to try and track shadow figures, it's a bit unreliable. So there's certainly other explanations for shadow figures. A shadow figure does exist. It's not necessarily a person. It could just be a trick of the eye.
That's Tim Mindham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.